Hey kids, Miss Kulkarni here. In this video, we will continue with our organic chemistry and we will talk about the radical halogenation reactions for alkanes. So what are radical reactions? These are substitution reactions when the hydrogen of alkane gets substituted by a halogen as it is shown in the reaction. In this reaction, this is representing any halogen like chlorine or bromine, and the alkane has this hydrogen. So this hydrogen is being replaced by the halogen X and we get haloalkane. This radical reactions, they progress through couple of steps, and these are the important steps. We got step 1, initiation of the reaction, step 2 is propagation, and step 3 is termination. So let's find out more details about each of this. Let's talk about how a covalent bond breaks and forms radicals. There are two different types by which a bond fission takes place. One is called homolytic and other is called heterolytic fission. As the name suggests, homolytic fission is the even fission, even breakage of the bond. A covalent bond has a shared pair of electrons. So what happens? Each element ends up getting a single electron if it is homolytic fission. And if it is heterolytic fission, then one of the element gets both the electrons and other element has no electrons. So that results into two opposite ions, cation and anion. In radical reactions, we get homolytic fission. So this is not a simple process. We need to have energy coming from UV light or heat, and that results into homolytic fission of halogen molecule. For example, here there is bromine molecule. It has got a covalent bond where electrons are shared. Each bromine atom takes its one electron, and what we got here, these are the free radicals. Each one is extremely reactive. Next step is propagation. It actually has two sub-steps. In the first step, the halogen, which is bromine in this case, that radical reacts with methane as it is shown here in the reaction. And bromine tries to pull that hydrogen. Again, the bond between carbon and hydrogen is a covalent bond. There is a shared pair. The hydrogen comes out with its only one single electron, and that ends up giving the molecule HBr. But with that, the methyl is left with again one electron. So we get that as methyl radical. Now the second part of the step is methyl radical reacting with bromine. It's going to pull one bromine atom from bromine molecule and it results into a bromine radical. And look what we got. We ended up getting here the molecule bromomethane. So we got one hydrogen substituted by bromine. Now this bromine radical is going to go back and do the same process and create more and more methyl radicals, and the process continues in this reaction cycle. The last step is termination step. The radicals are floating in the reaction mixture, and now all different type of radicals can come together. If they come together and they share that one electron which they have, they end up having a stable molecule and the reaction stops there. Let's see if you can figure out the products of this reaction. Look at this alkane. It's 2 carbon chain, 2 stands for eth. So we got ethane over there. And UV light initiates the reaction, and that's bromine here. So we are going to get bromination of the alkane. So the final product will be replacement of one hydrogen from this ethane by bromine. So what do we have? The compound will be called as bromoethane. Let's look at the next example. We got a cyclic alkane here and it is 6 carbon atom. So it will be called cyclohexane. And under UV light and bromine is going to undergo radical bromination reaction. And all carbon atoms here will be almost identical. So we can put at any position that bromine. And the compound will be named as bromocyclohexane. So radical reactions are pretty interesting, right? Now, will all the halogens work exactly same way? Not quite. If you look at the halogen reactivity, it is maximum for fluorine and it decreases as we go from fluorine to chlorine to bromine and iodine. Fluorine reacts violently and produces fluoroalkane. Chlorine and bromine react normally, but iodine does not even react. So we don't get iodoalkanes by radical substitution. Alright guys, I'm sure you learned a lot about radical halogenation reactions of alkanes. See you again in next video. Until then, bye bye.